Let's take a look at this problem. We got tangent theta plus secant theta is equal to 1. And our angle is between 0 and 2 pi. One technique is to rewrite everything in terms of sine and cosine. So tangent is sine over cosine, and secant is 1 over cosine. Now we never want fractions, so we'll multiply everything by cosine. So we got cosine times sine over cosine, and we got cosine times 1 over cosine, and we got cosine times 1. Well, here our cosines cancel and here our cosines cancel. So we're left with sine theta plus 1 is equal to cosine theta. Now, we'd like to get these into the same trig function if we can. And one way I can do that is by squaring both sides. So I'll just take sine theta plus 1 and square it. And I'll take cosine and square it. Now sine theta plus 1 squared, I can rewrite that as sine theta plus 1 times sine theta plus 1. Over here, when I square the cosine, that just gives us cosine squared. Now the reason why I couldn't square the sine and the 1 is because of that plus that's in the middle there. Since that plus is there, we just have to rewrite it this way and multiply everything together. FOIL it if you learned that technique. Sine times sine is sine squared. Sine times 1 is sine. 1 times sine is sine. And 1 times 1 is 1. Equals cosine squared. So that gives us sine squared plus 2 sine theta plus 1 equals cosine squared. Well, we'd like to get them all in terms of sine or cosine. Well, these are already in terms of sine here, but I can rewrite cosine squared. If you think back to your Pythagorean identities, you had sine squared plus cosine squared is equal to 1. And I can take the sine squared and move it to the right side. So we get cosine squared is equal to 1 minus sine squared. So this cosine squared that's on the right side we can replace by 1 minus sine squared. Well, we want to get everything over on one side and then see if we can factor. So I'll take both these items here over the left side. So we get sine squared. When I take that negative sine squared over, it becomes a positive sine squared. Plus 2 sine theta plus 1. And when I take that 1 over, it becomes a negative 1. Well, sine squared plus sine squared is 2 sine squared plus 2 sine theta. 1 minus 1 drops away. Okay, well, we want to factor out the GCF, which would be 2 sine theta. And that leaves us sine theta here plus 1 equals 0. Well, zero factor property. It says if you get 0 on one side and you factor the other side, you're going to set each factor equal to 0. So I'll set 2 sine theta equal to 0, and I'll set sine theta plus 1 equal to 0. Now in this one I'll divide both sides by 2, and we end up with sine theta is equal to 0. Well, my unit circle, here at 0 and here at pi, here's 0 and here's pi. This point would be 1 comma 0, and this point would be negative 1 comma 0. Remember, sine is our y part of our point on a unit circle. So they're asking us where is y equal to 0. Well, it's equal to 0 here, and it's equal to 0 here. So theta would be equal to 0 and pi. Now this one, I'll take the 1 over to the right side, it becomes a negative 1. And if I come down to this point right here, which is at the angle 3 pi over 2. This point would be 0, comma, negative 1. Now again, sine is our y part. So where sine is equal to negative 1 is 3 pi over 2. Okay, let's come up above. We said 0, oops, try a little bit more on that. 0 pi and 3 pi over 2. 0 pi, 3 pi over 2. Well, we need to check these. Because anytime especially you raise both sides to a power, you have to check it. But even more than that, when you rewrite them out of tangent and secant, you need to check your answers, make sure they don't cause an issue. So just to show how to check it, if I check 0, if I put 0 in, I'm going to have tangent 0 plus secant 0, and we're wondering if that's equal to 1. Well, tangent at 0, tangent is equal to y over x, which would be 0 over 1, plus secant. Secant is equal to 1 over x, and at 0, x is equal to 1. So I got 1 over 1, which is 1, so 1 is equal to 1, and that one checks. Now if I put pi in there, you can do this in your calculator even. We got tangent pi plus secant pi, and we're wondering if that's equal to 1. Well, tangent is equal to y over x, so at pi that would be 0 over negative 1. Secant is 1 over x, and at pi that'd be 1 over negative 1. So we get 1 over negative 1, which gives us negative 1. Negative 1 does not equal to negative 1. So the pi drops away. And then to check 3 pi over 2, we'd have tangent of 3 pi over 2 plus secant of 3 pi over 2, and we're wondering if that's equal to 1. Well, at 3 pi over 2, y over x, y would equal negative 1, and x would be 0. So right away that's undefined. Let me think that through. Y over x. Yeah, negative 1 over 0. So that one doesn't work. So it looks like our only answer is theta is equal to 0. Well, let me show you how to check that in the calculator. First off, I'm going to mode, make sure I'm in radians. And you see I have radians here. And then I'll press my y equals. Actually, let me show it a different way. Okay, so I'm in radians. I'm going to put in tangent 0, and I'll put my closing parentheses, plus secant. We don't have secant, but secant is 1 divided by cosine. It's 1 divided by cosine. Put 0 in, and that gives us 1, which is what it should. That's what's on the right side. So that one checks. Let's put pi in. So I'll do tangent, and then I'll do second caret for the pi, closing parentheses, plus 1 divided by cosine, then second caret for the pi, closing parentheses, enter. And that gives us negative 1, which we already knew that didn't check. Now let's do 3 pi over 2. So I got tangent 3 pi, so second caret, divided by 2, closing parentheses, plus 1 divided by cosine 3 pi over 2. So do 3 and then second caret for the pi, divide by 2, and press enter. We get an error domain. That's because it's undefined. Remember what we found when we talked about this right here. We get negative 1 over 0. So again, our only answer is theta is equal to 0.